I'm James Lindstrom,
I'm Kenny Bradley.
and we have made a Bluetooth-enabled microwave. Now to just demonstrate how this works, basically what you do is you can download this Bluetooth terminal app on your phone. And so if you go into the app and connect to the microwave, you can send commands, send commands such as if I send A, that represents the start button, and you'll see it'll start the microwave. Now I can send other commands over Bluetooth, such as the stop command to stop the microwave.
How we're able to make a Bluetooth-enabled microwave is we needed a way to interface and control the microwave, so we had to use a microcontroller. We have to be able to receive Bluetooth signals using a Bluetooth transmitter, and we have to be able to decode the button presses from the keypad. We decided to go the keypad route rather than directly interfacing with the magnetron itself, because the microwave takes standard household power at 120 volts and it has a transformer that ups the volts to 4,000 volts in order to power the magnetron to excite the filament to emit the electrons to rotate the bipolar molecules within your food to heating it up. And so we didn't want to interfere with any of the dangerous high voltage or high power components of the microwave, so instead we opted to directly control the button presses of the keypad, which operates at a much lower voltage. And just to give you an idea of how this works, here's our keypad that we used in our ECE3710 microcontrollers class in the previous lab, and we removed the leads at the bottom to interface directly with the ribbon cable within the microwave, which allows the leads from the keypad to interface with the microcontroller within the microwave itself. And so just giving you an idea of how this works, this is a 4x4 keypad that has 4 columns and 4 rows. And as you can see, the slightly lighter wires on the left are the different columns. And the 4 on the right are slightly darker and are the rows. And so whenever you press a button on a keypad, such as A, you will cause that circuit to be completed. And it'll cause a complete circuit between the 2 on the very end, in this case, when you press the letter A. And then whatever microcontroller or logic you have will interpret this lead and this lead as being the same, 0, will then interpret the letter A within that logic. We use the app within your phone to send certain characters that represent those button presses. Transistors are what enable different devices, such as computers, to selectively allow current to pass through, much like a switch that you use to turn on the light in your own home. But a transistor is different because it has no physical moving parts. Instead, it is a semiconductor, which means that at times it conducts electricity and other times it doesn't. And so what causes the transistor to transmit electricity is whether or not you apply current towards the middle, which effectively closes the switch and allows current to pass through. So that's exactly what we have here with our 8 transistors that simulate the 8 rows, and we have 4 columns that we have hooked up to a decoder or demultiplexer that will then selectively connect those circuits simulating a button press, depending on which code we are trying to, or button we are trying to stimulate.
And so to control these transistors, we use the Bluetooth connection to activate GPIO pins on our microcontroller. And these GPIO pins will then activate these transistors and complete the circuit as Kenny described. So to get the Bluetooth connection to work on the microcontroller, what we did was we had a UART connection to this HC05 Bluetooth transmitter. And that UART connection allows the microcontroller to communicate and receive signals from the Bluetooth transmitter. And this Bluetooth transmitter is configured in a slave mode. So what that means is that your phone is the device that's controlling and sending signals to the HC05 transmitter. And when the HC05 transmitter receives these signals, it then creates a queue inside the microcontroller, which is then used to receive messages from. So the microcontroller interpret what the messages are from the your phone and activate the transistors to so that the circuits can be finished and a button can be pressed. So yeah, this is our final project, and just in summary, it's a Bluetooth-enabled microwave that's able to control button presses with your phone.